Okay. Guys, any questions about the materials we covered yesterday? Nothing? Okay. Guys, before we continue, we are going to talk about the even and odd functions. Have you had these concepts before? Hello?
Maybe no.
Maybe no. Okay, let's see. Because we need that concepts before we talk about the cosine function. Okay. It's a kind of a side note, which it helps us on the trigonometric function, but it's always always good to know about this concept. It's going to be the April 17. It's going to be the functions 11. Okay, ready, guys? Shall we move on? Yeah?
Yes.
Okay. Guys, when we talk about the functions, we consider the functions in two broad categories. When we talk about the functions can be classified in two different types of the functions. Some of the functions that we're going to talk about, we call them as odd functions. Odd functions. Do you see that, or there is too much light there? Hello? You see, guys, my handwriting? Okay.
It's a little bit hard to see.
Okay, how about now?
Yes, it's better.
It's better. I think maybe that's too much light then. Okay, guys, when you talk about the odd functions, what do we mean? When we talked about the functions, we were able to decide to define a variable, a single variable, and we construct a function as a machinery who transforms this function. We said that, for example, the f is a transformation of the single variable x into a range of the possible values which it takes from the domain. But imagine that also we talk about, for example, the f of minus x. What do we mean by f of minus x? It means that, for example, if anything is x, you transform it to the minus, you multiply by the minus. And we come to define it in a broad way that if f of x is equal to f of minus x, but with one minus sign before that, then we say that this function is an odd function, which very easily you see that the f of x for an odd function, the f of x plus f of minus x should be always equal to what? Should be always equal to 0. For an odd function, then we say that f of x plus f of minus x, it always goes to 0. That's the identity that we come to talk about, that about the odd function, that any odd functions adding to its transformed of minus x should take you to the 0 value. What are the values of the f of as an odd function? For example, as an example, we say that, for example, f of x should be, for example, x squared. You see that if you write f of minus x, what do you get at the end? You get what? You get minus x to the power 3. Then it takes you to become what? Minus x3. Correct?
Yes.
Yes. Then in that case, you see that, oh my God, f of x is x3, but f of minus x is minus x3, which is minus f of x. Then you see that if you add them together also, the function becomes what? Gets to 0. x3 plus minus x cubed becomes what? Becomes 0. Then that's the definition of, let's say, an odd function. And if we want to talk about the odd function, we saw that, for example, if you plot them also geometrically in order to identify these odd functions, the best way to identify them is that they are symmetric with respect to the origin. For example, if, imagine that if x cubed, look at that, let me share my screen with you. Let me share my screen and plot this function. You see that how this is the symmetrical with respect to the origin. I'm going to share my screen. I'm going to share my Desmos. Guys, you have my screen, huh? Okay, on my screen, you get that. I'm just going to plot this function, f of x equals to what? X cubed. Look at this function, guys. This point, 0, 0, is the point of symmetry with respect to the odd function. You see that, for example, this point whenever you just go down, you see that the points get, I should say, symmetric. For example, if there is a point here, 2 and 2, with respect to, for example, the origin, you should get to the minus 2 and 2. You see that? And that's what we call the origin, is the, I should say, is the symmetry, is a point of symmetry with the, let's say, with the function. Also, I'm just going to plot this function, f of x equals to minus x to the power 3. No, this one. Look at that. Look at these two functions, guys. The blue one is this function. The blue one is the minus x squared. The red one is the x squared. You see, if you add them together, they are, because they have just the same thing, you just get to the 0 then. You see, that's the even function, and that's an odd function, and they're all symmetric to, I should say, to the origin. The symmetry is for the function itself, and it is with the origin. I'm just going to give you some more exercises with respect to the odd function, but we need that concepts today only because we want to talk about a trigonometric function. Okay. Then, for example, if I plot this function, it is x cubed. You see that the origin is a point of symmetry. Guys, do you know what does it mean, symmetry?
Yes.
It means like the mirror image. For example, if you're at point A, with respect to the origin, you get here, and they are exactly like each other. But with respect to the, you just put the mirror at the origin, and these 2 points are exactly behaving like each other. For example, we talk about the symmetry when we were talking about that unit circle that we talked about that a week ago, and we saw that when you are locating a point, localizing a point on the circumference of the circle, how you can find, because of the symmetry, how can you find at least 3 other points which behaves exactly like the point that you started with. And we call it, they are like the brother or sisters points because they share the same characteristic behavior. And we were able to do that just because of the concepts of the symmetry, which it was introduced by the circle. But now here, we are talking about, again, but the symmetry now is introduced because of the nature of the odd functions, that the origin is the point of the symmetry. Okay, any questions, guys, so far?
No. Wait a minute. Can you say it again? I don't hear all the things.
Sorry, say that again. After I said to you,
Yes, I just come 2 minutes. I'm late. Sorry.
oh, no worries. We talked about the odd functions, Ferris, and we said that the odd functions is like that. If you have f of x, the odd functions is like that. If you change the arguments from x to minus x, then the functions becomes like that. F of x equals to minus f of minus x, or minus f of x equals to f of minus x. By changing the arguments from x to minus x, then you get the function still equal, but they have a minus in terms of the value. For example, like this function, f of x is x cubed. If you change the arguments from x to minus x, and you plug minus x inside the x, you get to the same function. Look at that, everyone. Look, what is the argument of this function? This is x, correct? If you put x, if you transform x to minus x, then put it back to the function to see what do you get. It means that for the x, you put minus x. You see these flashes, or you cannot see that because that's the orange color. You see that, or do I have to change the color?
I can see it.
Okay, then you see, for the odd function, if you are starting with the point x, and then you transform it to minus x. For example, the point x is 2. On the positive side of the coordinates, the point is 2, then you change it to the minus 2. You see what happens to the function. You change it and you step back. You step back to see how the function behaves. Depending on the behavior of the function, when you change the x to minus x, you can decide if the function is odd. Then that's what I did. The x is there. I change the x to minus x. Then from minus x, I see what? I see that if I put back minus x inside the argument of the function into the machinery, I put x to minus x, then I have a flash going, put in minus x to the x cubed, then it becomes minus x divided by to the power 3. Then it's obvious to you all that it becomes minus 1 to the power 3 becomes minus 1, and x to the power 3. Then at the end, you come to compare these two results. When you're a step back, you see that f of x is x cubed, f of minus x is minus x cubed. Then say, the function is odd. And if a function is odd, and if you plot it geometrically, you see that if a function has a point of symmetry with respect to the origin, it's a proof. It's a geometric proof that the function is odd. And you see that if I plot x cubed, it becomes this function. And symmetry is around the origin because you see that whatever happened to the right side, upside of the origin, it's exactly happening at the lower side of the origin. Then you see that the origin 0 is a point of symmetry for the graph of this function. Then geometrically, you can show, you can prove that the function is odd. That's the analytical proof, but that's a geometric proof. Yes, Faris?
Yes.
Faris? Awesome. You got it?
Yes.
Okay. I'll just give you one example in terms of the odd function to see that if, as an example, before we just go to the even function, because it seems that it's worth talking about the even or odd functions before we just move on with the trigonometric function. It's going to be worth to talk about that. Then I say that as an example, I give you two examples. The first example is going to be this. I give you the f of x is x 2 plus x plus 1. That's the first function. And the second function, which I'm just going to give that to you as an example, is this. I call this function g of x. It becomes x to the power 5 plus, no, let's start with x5 at this stage. Then I add one term to that. And the reason I just have a plus there, that's why I just want to add something to that. I do that later. Then please, guys, based on the definition which we had, to see if these two functions are odd functions or not. Two-way, analytical demonstration and geometrical demonstration, both methods. Any questions? You know what's going to happen? Okay, give it a go. You try. Guys, are you working on it?
Yes.
Are you done with the first one?
Not yet.
Uh-huh. Okay. Guys, are you done now? Okay, let's do that together. I'm starting with the first one. X squared plus x plus 1. What do I have to do? The first thing which I have to do is that I have to make a transformation. What is that transformation? Is that I have to change the x to minus x. That's the first transformation, right? Okay. If I'm going to do that, I'm going to put them as a result. If I'm going to do that transformation, then I'm just going to write f of minus x, because I transformed x to minus x. Then what do I get? I get wherever I see x, I close my eyes, I put minus x and wrap it with the argument. The first argument is x. It becomes minus x, but to the power 2, correct? Plus, I see x, I put minus x, and I know that the power is 1, and I don't bother even to do that. Then plus 1 is something which is left behind, right? And now, what's going to happen now? I just step back to see what do I have here. I have minus x to the power 2. Is it equal to x squared? It's x squared plus minus x. It's minus x itself, and I have plus 1 at the end. right? Guys, are you there?
Yes.
Look at this. This is my f of minus x. And I have f of x. Sorry guys, my cell phone is ringing. Give me a second. Guys, look at that. Can you compare f of x with f of minus x? Can I say that f of x, let me use a red color. Can I say that f of x and f of minus x, these two functions, they can be equal, but with the minus sign before this one or that one? Is it valid? Compare this one with this one. I have plus, I have plus. I have minus, I have plus. If it's supposed to be like that, I had to have minus x squared minus x minus 1. That's right. Because what is minus f of x? Minus f of x minus f of x was what? Minus f of x becomes minus x squared minus x minus 1. You see that? But that's f of minus x. Is this one equal to that when you just change the x to minus x? No, because f of x is this, f of minus x is this, and it's way different than this to the minus f of x. Then as a result, this is not valid. And this function is not an odd function. Not odd. As a result that we get. Any questions on this?
No.
It was two-step problem. Transformation of the x to the minus x, then finding the transformation of the minus x under the function transformation, and then step back to compare this result with this result. And we see that they are not odd functions because this equation is not valid. Because f of minus x is not equal to minus f of x, because the minus f of x is this one. You multiply minus to the f of x becomes this one. You compare f of minus x with this, you see that they are way different. Then the function is not odd. Rose, Philip, Ferris, Gloria, are you 110% fine with these questions?
Yes.
Yes.
How about the boys?
Yes.
And how about the Ferris? Okay. And now we just move on to the other one. It's way easier. And I say, imagine that for this one also the same thing. I make a simple transformation and I say I transform x to minus x. Okay, in case what happens, then what do? I just put this minus x inside the machinery of the function g of minus x. It means that I put minus x instead of the x equals to minus x to the power 5, which means that it becomes minus 1 to the power 5 x to the power 5. Minus 1 to the power 5 is odd number. It means that when minus 1 gets raised to the power of an odd number, we still have minus 1. then it becomes minus 1 times x5. And now you see that g of minus x becomes minus x5. What is minus g of x? It's minus x5. It's so simple to get it from there because I only multiply minus 1 to this function, becomes minus 1 times x5. Is this function equal to this function? Yes. Is it right, guys? Then as a result, because g of x equals to minus g of x equals to plus g of minus x, because this relation holds, you see g of minus x is minus x5, g of x multiplied by minus 1 is this, and because they are equal, then it means that that's an odd function, right?
Yes.
Awesome. Any questions? Rose, Philip, Gloria, Ferris?
No.
No.
Everyone's good? Guys, great. Then I give you a little bit more cool stuff to work with. Now we continue our example. This example is going to be the same function. I call that h of x. And you say that it's going to be the function x to the power 5, which we had, plus sine of x. Ah, beautiful function, huh? Please spend 2 minutes on this. It's so much learned from this example. Guys, who's done? Who is the champion? Who finished it?
Me. I finished.
You finished it. Is it odd or not?
It's odd,
It's
I-
odd.
I think.
Interesting. How about the others? Philip, Gloria, Ferris?
Not yet.
Not yet. No worries. Is it good to have 1 minute?
Yes.
Awesome. Okay, let me do something extra to the things we do by plotting this function. First of all, I have to review something before we move on about the sine function while you are spending your time to work on this problem. What was that? Guys, please, if you're still working on that beautiful problem, just give me your ear for 1 second. I'm going to discuss something here before we move on. Look at this one. I am showing you the paper which I have, and that's essentially, as you can see, that is a unit circle. I hope that you can see the circle because this is drawn with the pencil. You may not see that, but that's a circle, unit circle with the radius 1. And I have the Cartesian coordinates x and y. This is going to be x and y, which the center is coinciding with the center of the circle. The thing which I do, I just move counterclockwise to pick up an angle, and I call that angle x. And that's a plus direction. That's a positive direction, because you learned yesterday that when you are selecting the angles on the unit circle, if you are walking on that circle counterclockwise, I mean the opposite direction of the clock, then it's going to be a positive angle. And at the same time, I'm just going to do what? I'm just going to pick up the same angle. Let me choose a different color. I'm going to pick up the same angle x, for example, if it is 40, the same 40 degrees, but by moving clockwise. I mean by rotating along the direction of the clock, and I call that x. These two angles are similar, are the same, except one fact, that x is positive and x here is negative, because this one is counterclockwise, this is clockwise. Then that's the thing which I know, that x and x are the same, but because of the change of the rotation, they are different in terms of the sign. I'm going to measure the sine of this angle. In order to measure the sine of this angle, as you have learned it, I should say, yesterday, oh no, not yesterday, last week, you are just going to project it from this point to the y-axis, and whatever you read on the y-axis, which is y, it is defined as the sine of that x. Is it correct? We know that the sine of the x equals to y divided by the r, which is the radius. And because we are on the unit circle, we know that the unit circle, the name implies itself, this is more expressive than anything else, that the circle is the unit of the length. It is 1. Then y divided by the r, this is essentially y divided by 1. That it means that this is anything divided by 1, it's itself. Then it means that y divided by r, which is 1r, we get the y. That's we know from the past. But at the same time, I'm going to find the sine of this angle, the x, which is minus x. Let me just put minus x not to have it confused. We have x in green, which is counterclockwise. We have minus x in orange, this is clockwise. Then what's happened to the sine of this angle? What do I have here? I have, again, the same thing. I project it to the y-axis. And the projection on the y-axis, which is going to be y, It's going to be my sine. Then what do I say? I say here, then the sine of minus x, because the angle is minus because the rotation of the angle was clockwise. It's going to be the same thing. Whatever you read as a y on that y coordinates divided by the r, it gives you the y. But the problem is that, guy, what is the relationship between this y and this y, meaning that these angles are symmetrically the same and equal? Aren't they the same? Is y equal to the same y because you have the same angle?
No. Minus 1.
Oh, that's what I want to say. Fantastic, Rose. In terms of the absolute value, they are equal. But as Rose mentioned, because one y is in the upper side of the origin, which is a positive region, is positive, but the other y, which is equals to the other y, but this is below the origin, it gets the minus y. Then it becomes minus, then it becomes minus. Then you will see that, guys. Any questions? Any questions on this part so far?
No.
No. Gloria, Philip, and Ferris?
Nope.
Philip?
No.
Okay. Oh, you're yawning. You're tired?
I just wake up, that's why.
What time did you wake up?
11.
What time did you go to bed last night?
3, I think.
Oh my God, that's fantastic, man. You are just running a life of absolute freedom. No physical school. Okay. And now, then guys, as you will see, if I have these two angles, but they are positive and negative because of the depending on the rotation of the angles, in terms of the sine, I can come to this very important conclusion as what I demonstrated here. And that's the important conclusion, that the sine of x should be equal to the sine of minus x, but you see there is one minus sign involved. Then it means that I have to either put the minus sign here or the other way. I put it here. You see? It doesn't matter where you put the minus sign, but it doesn't matter at all. It can be any side. It can be next to the sign minus x, or it can be next to the sign of the x. It doesn't matter, but I prefer to put it on the left side because I can always make sure that is for checking. That's the best way. I put the minus next to the sign and see what happens there. Okay. And now, then as a result, guys, you see this happens. What can you understand from this identity? That the sine of minus x is equal to the sine of the x, but with the minus sign next to that. Does it mean that this is something which we have learned before? That the f of x minus f of x equals to f of minus x. That's a definition of an odd function, right? Then as a result, this notation, this demonstration, starting from that unit circle, with two angles, absolute value the same, but rotations are different, clockwise and counterclockwise, we reach the conclusion that the sine of the x is an odd function. Correct?
Yes.
Fantastic. Any questions, guys, on it?
No.
That's super important to know that the sine of the x is an odd function. Then if that's an odd function, you can expect that geometrically the functions, the plot of that function, the graph of that function is symmetrical with respect to the origin. Correct? Okay. And now, we proved, then coming back to the same example which we had, we proved that the sine of the x is an odd function. Then that's okay so far. Now, in order to go back to the original problem which we had, I know something very easy. I know that in order to show the oddness of the function, I simply transform the x to what? To minus x. And that's all the thing which I have to do, nothing more, nothing less. X is transformed to the minus x and let it be to see what happens. And now, as I'm at that stage, I'm gonna come to just put minus x, put it back to the system which I had to find what is h of minus x. H of minus x becomes how much? Becomes minus x to the power 5 plus sine of minus x. It's always easy to find it because wherever you see the x, you push the x aside and instead push the x aside and replace it with minus x, as what I did. I went back to the original equation. Wherever I saw x, I push it aside and I replace it with minus x. Let's simplify that further. It means that h of minus x equals to what? Minus x to the power 5 becomes what? The same thing. Minus 1 to the power 5. 5 is an odd number. Then minus 1 to odd number power becomes minus 1. Then I have minus 5x5. And what is sine of minus x, guys? Sine of minus x.
Minus sine x.
That's right. Based on the things that we proved 2 minutes ago, becomes minus sine x. Okay. And now, okay, I reached to this point. Let me highlight this one. Okay, and now, in order to show that if a function is odd or not odd, I have to multiply the original function to minus 1. If f of h of x is there, what is minus h of x? Minus h of x is very simple. I know my f of h of x is there. I put minus to h argument, minus x5 minus sine of x. And now, that's the time to compare these two arguments together. Because I want to show that. I want to show that the f of x, let me use this color. Why I'm doing this, I remind you again, because I want to show that the f of x is related to f of minus x, but with the one minus next to this one. That's the definition of an odd function, correct? Okay, that's fine. I have f of minus x. I have h. It doesn't matter. That's the name of the function. It doesn't change the generality. I have f of minus x. H of minus x is what? This function. Minus x to the power 5 minus sine x. And I have compared it with f of x, which is multiplied to minus, which is this one. Minus x minus sinus of x. Aren't they the same? I mean, this function, isn't it like this one?
Yes.
They're equal. Then as a result, you conclude, because this relation holds, that this function is odd. So beautiful, huh? Oh my God, I like the way which I mix the colors together. It's so lively. It's going to be page number 3. Guys, any questions on this?
No.
How about you, Gloria, Philip, and Ferris?
No.
No.
Gloria?
No.
How about Ferris? No one has a question?
No.
Okay, now, guys, I think that's the good time. How about the break? We take a break. Is it good?
Yes.
Awesome. When we come back, we talk about the different type of the functions, then we move on. Then what time is it now? This is 12:05. Let's come back by 12:20, sharp 12:20. We continue by then, huh? If you have no questions, enjoy your break. See you in 15 minutes. Ciao. See you later, guys. Hello guys, welcome back. Okay, what are we going to start now? We're going to start in with this concept right now. Okay. Any questions of the previous topic which we talked about, the odd functions?
No.
No, everything is fine?
Yes.
Okay, nice. And now we're going to talk about the different classes of the functions, both analytically and geometrically. And that class of functions, this is called even functions. If you guess that you study the odd functions and you expect to have the even at the same time, that's you're right. We are going to talk about the even functions, but the even functions, what are they? For the even functions, we can just bring the same argument. Even functions. Okay, for the even function, we talk about the type of the functions if you study like that. For example, imagine that we have an argument x. And with that argument, I say that if I transform it based with a function, and I have another function argument, I mean, I just transform into minus x. I say that, okay, it is going to be the x. I transform the x to the minus x. Then I say, okay, then I find f of minus x. If I can show analytically and geometrically that the f of x, look at that, I had the transformation x, I just come here. If I say that the f of x should equal to f of minus x, you see, I have minus x also from here, and I show that the equality exists between these two type of functions, essentially by saying that when you make the transformation to the minus x and the function doesn't change, its nature remains the same, and it is, they call that this is invariant with respect to the transformation of the x to the minus x. The function becomes invariant. It means that the function doesn't change. Even after the transformation, the function still is itself. Then the even function you can think of them as the type of the functions which they are invariant with respect to transformation of the x to the minus x. As an example, I'm just going to talk about the most simplest cases of the functions which you have seen, and that's the quadratic function. I say f of x is going to be x squared. Let's put it, let's say x squared plus 1. In order to prove analytically, guys, do you see what I write?
Yes.
Yeah, because I got the message here that there is law resolution. Sorry about that if the quality is not great. But everyone can see what I write, huh?
Yes.
Good. Then what I'm going to do is that I come to say that, okay, in terms to show and prove that the function is even function, I have to first make a transformation. And that transformation is this: x is going to be transformed into minus x. Then we replace x with minus x into the machinery of the function and step back, take our breath to see what happens to the function. Let's do that. I'm going to take minus x and take it back into the function itself and step back to see what happens. Then it becomes what? Becomes f of minus x. Wherever I see x, I put minus x. F of minus x becomes minus x squared plus 1, which is a constant, and it doesn't do much. Then in that case, what do I end up with? Is it okay if I say that if I can show that f of minus x, I know that the minus x to the power 2 becomes minus 1 to the power 2. The exponent is an even number, then minus 1 to the power of an even number is always plus 1. Then I end up with x to the power 2. And the plus 1 remains at the end. And that's what I get. Here as the f of minus x. And look at this one. We say that based on the definition of a function in an analytical way, that the function needs to be even, it's invariant with respect to the transformation of the x to the minus x. We say that the function after transformation is equal to itself. Then if my f of x is x squared plus 1, and my f of minus x is x squared plus 1, if I compare these two functions, can I say the function is even?
Yes.
That's right, because I see that the f of x equals to the f of minus x. Then as a result, analytically, based on the definition, we say that the function is now even. Okay, before I show you that in terms of the geometric representation and proof, do you have any questions, guys?
No.
No.
How about Philip and Ferris?
No.
How about Ferris? Ferris? Okay. Look at this. I'm gonna plot if this is 1. You know that if x squared is a quadratic, when you have 1, you shift everything up by 1. If I want to show the plot by its graph, it becomes this. It's a quadratic function. You see this plot, guys?
Yes.
Yeah. And if I ask you, before I just I help you to find the answer, do you see any kind of a symmetry into this plot?
Yes.
Okay, what is that symmetry?
As x equal to 0.
Oh, that's great. You mean the y-axis, huh?
Yes.
That's fantastic. Guys, look at that. Imagine you put a mirror into the y-axis. This is a mirror into the y-axis. is it like that, that if the left side is the image of this one or vice versa? Because if the distance of this point to the y is a, the same distance to the same point on the other side is also a. And we say that, imagine that if x equal to 0, as Rose said, which is the equation of the y-axis, it becomes as a kind of a mirror. You see that these two sides are the same. Rose, imagine this side of the graph is you, okay? And when you look at the graph, look at the mirror, which is essentially the y-axis with the equation of x equal to 0, you would see your image there. That's right.
Yes.
And why we call that an image? What do you expect from your image, Philip? Philip?
Mm-hmm.
What do you expect from your image? When you look at yourself at the mirror?
Symmetry.
Symmetry, that's right. Why symmetry? We mean that you, guys, listen to this example that's very crucial. We say that what do you expect from your image at the mirror is that your image behaves exactly as you. Philip, if you are standing at the mirror and you raise your arm, do you expect your image also raises his arm?
Mm-hmm.
If you laugh, do you expect your image shows your muscle of the face is moving and shows your laughter?
Yes.
That's right. Is it possible that, for example, you look at the mirror and you raise your hand and the picture doesn't raise his hand,
No.
the image? No?
No.
It becomes very scary if that happens, huh?
Yeah.
If it happens to me, if I'm standing at the mirror, I raise my arm and the image doesn't raise his arm, it's gonna be very scary.
Mm-hmm.
But
True.
the point that we make is that, Gloria, that when we say that the image behaves exactly like you, it means that that both of you have the same characteristic behavior. If you study the image, it means that you study myself, or you study your image, it means that you know everything about your face. That's correct. And that's why we talk about the symmetry with so much emphasis. And about the symmetry of the y-axis for even function is that if you know the behavior of function, on one side, you know exactly and deterministically what's happening on the other side because they are the mirror image of themselves. For example, if Philip is on the right side and he's laughing, I know for sure that Philip on the other side is laughing because that they are mirror images of each other. That's why the axis of the symmetry for the functions which they are even is crucial. You know one side of the function and you are sure the other side is going to be the same. It behaves exactly like that. Any questions, guys, about the material?
No.
No, everyone is fine.
Yes.
Great. Okay. And now, we go to page number 5. And at page number 5, I'm going to give you an example that you do it yourself. Where is my ruler? Here it is. I give you 3 examples. The first one is this. I say the function f of x is going to be x5 plus x4 plus x minus e. Ha! E is a natural number. Okay, the other function Mm, I'm gonna give that to you. Depend on the time. What's the time, guys?
12:37.
Sorry, 12:30. Okay, I think that's
12:37.
okay. You have some time. The other function I give you is this. G of x is gonna be x squared plus cosine of the x. Yeah, give it a try. Then I join you all. We solve it together based on the definition of the odd and even functions. Hey guys, can I start the first one and you help me along?
Yes.
Okay. Guys, I look at the function and I ask myself if this function is even or odd. Now, because I have two definitions handy, I know the definition of the odd function and I know the definition of the even function. And now what can I do? I ask myself if this function is odd or even. Then I have two tools to assess. I know that the starting point for any of these functions, one of my markers seems that it died and I have to put in the garbage, is that I make the simple transformation that x goes to minus x and put minus x based on that transformation into the machinery of the function and take a step back, sip at the coffee, and watch to see what happens. Then I decide at the end. I'm going to make the transformation before I just step back to watch and have my coffee. What's going to happen? I put minus x into this function, which it means that I put minus x, then I have f of minus x equals to minus x power 5 plus minus x power 4 plus minus x here, and at the end, minus e is a number. It's a constant number like the pi, but e is 2.16 something at the end. That's the natural number. We learned about that when we talked about the logarithms and natural logarithms. Okay, now I have this one. Then I have to simplify that further, which it means that the f of minus x equals to minus x, all of them to the power 5. It means minus 1 to the power 5 times x to the power 5. What is minus 1 to the power 5? Minus, huh? Then becomes minus x to the power 5. I have minus x to the power 4, which is minus 1 to the power 4 times x to the power 4. Minus 1 to the power 4 becomes how much?
1.
1, that's correct, becomes plus 1, x to the power 4. And I have plus minus 1 times x, which is minus x itself. And I have minus e at the end. Let's highlight this graph, the function. Let's highlight this function because we have to make a comparison. And now that's the time that you have to take your coffee and step back and observe and compare. to see what has happened. Guys, is this function equal to this function? If this is, it means that that's an even function.
No.
I mean this function to this. As a comparison, I mean compare this function to this function. If you compare them, as Rose said, that they are not equal, huh? Because I have minus here is plus. It's minus here is plus. There are two different functions. Then it means what? Then it means that as a result of this transformation, I have f of x is not equal to minus f of minus x, which it means that the function is not even. Correct?
Yes.
Is it odd if this is not even?
No.
That's great. How about Gloria, Philip, and Ferris? What do you think? If this function is not even, can we say this is odd?
No.
How about Philip?
I'm not sure.
Okay, let's, Gloria, do you know if this function is even or odd? Why? Why it is not odd?
I don't know.
How about you, Rose? Ferris, you are still not here, huh? I think Ferris just opens the camera and logs into the Zoom and he steps away. Okay, how about you, Rose? Can you explain to us why this function, although this is not even, but at the same time this is not odd? Can you explain why?
If fx function is odd function, it's equal to minus x power to 5 minus x power to 4 minus x and minus e.
Plus e, because you multiply, yeah.
O plus e. And it's not equal between the two functions.
Mhm. That's so true. Thank you very much, Rose. Philip, do you see that? So far, Philip and Gloria, you are okay to understand that why this function is not an even function. You're okay with that concept, huh?
Mhm.
Yes.
But it's not even odd, because if this is supposed to be odd, it means that the f of minus x, the transformation of the function when you transform x to minus x, should equal to the minus f of x. It means that you multiply this to the minus, 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 minus. But if you compare them, you see that this one is x4, this is the same. And that's, as a result, it shows that the function is not even odd. Make sense?
Yes.
How about you, Philip?
Yes.
Awesome. Now, guys, then as a parallel, as a good thing about the story is that you see that you can see some functions that they are neither odd nor even. There are some type of functions like that that not they are not even, they are not odd, and they are somewhere anywhere, but none of these two categories then. Uh, and now we go to the last example of the day. And what time is it now? Let me see, 46. It's in, oh, we have enough time. Okay, let's do this one. Who is done with this example?
Me?
You're done, Rose?
Yes.
Awesome. How about you, Philip and Gloria?
Mm,
Do you need some time? Is it a good 1 minute?
yes.
Yes.
Awesome. Okay, let me do some stuff. Guys, I have to tell you, we are gonna have another guest speaker for the week after next one. She got the admission with the average of 96% to one of the most competitive programs in Canada. She has been going to one of the public schools, which is very popular, and she's gonna come join us on a Zoom, and she's gonna talk about her story. And she got 96 also for the advanced function and function 11. She's gonna share her story with you, that how, and also it's good to know that program because it's one of the best programs in the North America, which is offered at the McMaster University. And I'm gonna bring you here to talk about that, and you also research on that because it's life-changing, that program. And she's gonna join us in the next 2 weeks. Are you excited for it?
Yes.
Great. Okay, now, guys, before we continue, I need again to show you something. Okay, now, look at this guy, guys. That's the exact thing that we did for the sine function. Now we are going to do that with the cosine function. The first starting point, as usual, is that I'm just going to pick up an angle, which is this. I call this angle, call this x, because this is counterclockwise on the unit circle, it's going to be a positive angle. I'm going to do the same thing. I'm going to come here to pick up a different angle, but this angle, it's picking up the same value for the x, but it moves to the opposite direction, to the clockwise direction, which it becomes minus x. And now, I'm just going to find what is their cosine. I know based on the things which we learned before, when you want to find a cosine, what do? You come here to project on the x-axis, and you read the x, and also the same thing. And you know for the cosine, you know that, guys, for the cosine of the angle x equals to what?
X divided by R.
Fantastic, Rose. Thank you. It's going to be the x, whatever you read on the x-axis, but you divide it by the radius of that circle, because always remember, when you want to define the trigonometric ratio, you are always bound in a unit circle, and you're also bound to the circumference of that circle. Then always you are bound with a radius. The radius is not going to be less than r or greater than r. It's always r. But because we call it a unit circle, r is 1, then we have x for the cosine. But how about the cosine of the minus x? Look at that. Its x is going to be here. I'm going to project it all the way up there. You see this, guys?
Yes.
It seems that apparently these two have the same x projection for those two angles. You see that? The one which I highlight in the black? Yes?
Yes.
And you see that, guys, that this one is, it seems that the x is shared. Then as a result, what is the cosine of the minus x?
X.
That's right. I wish if I had the argument something different, but my God, I screwed it. Guys, this x is not with this x the same. I should have said cosine of y or cosine of minus y. These two x's are not the same with these ones. Let's put that x bar. It shows that they are different. Then as a result, you see that with the cosine of the x, if x is transformed into the minus x, it means that for one of them, you have the transformation counterclockwise. For the other one, you have the transformation clockwise. And at the end, you same to the same ratio of the cosine. And they are equal. Then as a result, I can say what? I can say that, sorry, I'm going to write this one here. I hope you see that. Then I can say that the cosine of the x equals to the cosine of minus x. You see this one here?
Yes.
Huh? What is this definition of an even function, right?
Yes.
Because you say that if I transform the argument of the function and feed to the minus x and feed it back to the machinery of the function, I get the same result. That's the definition of the even function. Then we learn that the cosine of the function is always an even function, right? Guys, please write that on your brain, that the cosine of x is an even function. But we saw that before, the sine of a function is an odd function. It's always good to know these two ones. The cosine is even, the sine of odd. Okay. Any questions, guys, on this?
No.
How about Philip and Gloria and Ferris?
No.
No. Okay, and now I go back to this. I'm gonna do this one. I'm gonna decide if this is even or what. The first thing which I know to have to do, I do this transformation. I say I take my argument of the function, which is the x, transform it into the minus x, then feed this back into the function, which it means that I'm looking to see what is g of minus x. Wherever I see, I put minus x squared plus cosine of minus x. Guys, you see what I'm writing?
Yes.
And now, what is g of minus x here? Becomes minus x to the power 2 becomes how much?
X power 2.
So true. And now here's the trick and what you learned 2 seconds ago. The cosine of minus x. How much is that?
Cosine X.
That's right. Cosine minus x is equal to cosine x. That's why cosine x is an even function. Becomes plus cosine of x. How beautiful. How beautiful is that? And now, guys, please compare this one to the main functions which you had, which is g of x, x squared plus cosine of the x. Are they the same? Are they equal?
Yes.
Then we see that g of minus x is equal to g of x, which is a definition of an even function, right? Everyone is okay?
Yes.
Any questions? Rose, Philip, Gloria, Ferris?
No.
No. And now let's plot this and we check the symmetry on that function. What was the function? We had g of x equals to x squared plus cosine of the x. Oh my goodness. Oh, sorry, I forgot to share my screen. Oh. I forgot to share my screen. Then, guys, do you have my screen now?
Yes.
Fantastic. Look at this. Look at this beautiful function. Let me minimize it a little. That's the function. That's right. It was x, oh, sorry, x squared plus. Oh my God, that function is a little bit creepy. Plus. There is something wrong. It should not be like this. Plus cosine of x. Imagine if that's going to be the plot, which is surprising because I expected it should look different. Look, but this one is different. Anyhow, if that's the plot, guys, do you see the x equal to 0, which is the equation for the y-axis, is the line of symmetry for the function. Whatever you have on the right is matching with whatever you have on the left. Correct?
Yes.
Awesome. Then you see that even geometrically, you see that this function is an even function because there's a line of symmetry, and the line of symmetry is always y-axis. Okay, let me stop sharing my screen and go back to my page. Okay. Okay. Now, as a very last thing we are going to do, we are going to talk geometrically about, let's say, 4 functions very quickly before we catch up by next weekend. Guys, I'm introducing some function to you. You only tell me if they are odd or even. I'm going to go ahead with this function. If f of x, it's going to be secant of the x. Is it even or odd? Who said odd?
What's the secant?
Huh?
What is the secant?
Oh, I haven't shown that to you?
Yeah, not yet.
Oh, okay, okay. Oh my God, I'm so sorry, guys. It was my mistake. Guys, we talked about the trigonometric ratio, sine, cosine, tangent, and cotangent. That's right?
Yes.
If you take the inverse of that, you say that, for example, if you have, I'm introducing these 2 types of the functions to you, then that's how much time do we have? 10 minutes, huh? Less than 10 minutes. Almost 10 minutes. Guys, please, everyone is there. Guys, please say your name if you are there.
No. Gloria.
And?
Philip.
Okay. And guys, Philip, did you wake up eventually or no, you still feel sleepy?
No, I'm already wake up.
Oh, okay, nice. Look at this one. When we talked about, let's say, guys, the cosine of the x. What was the definition of the cosine of the x?
Y divided by
You mean
R.
the x, huh?
Oh, x divided by R.
Let me erase this because I should not put x there. I said cosine of the angle alpha that we talked. It was what? It was the x divided by what? R. Yes, everyone. Yes, Rose, Philip, Gloria. That's what you learned before. that the ratio is whatever you projected on the x-axis, you divide it by the radius of the circle, then you end up with the cosine as a ratio that you're looking for. But guys, what happens if I come here and inverse the cosine? I say, now I have 1 over cosine of the alpha. I inverse it. I say cosine of the alpha, I flip it, the top becomes the bottom, bottom becomes the top. Then if I flip the left side, then I get to the right side what? R divided by the x, correct? But however, in terms of the trigonometry, some people in the past, they say that instead of writing 1 over cosine of the alpha, which it always happens, when you work, you have always the inverse of these functions. Instead of writing that, we call this function, instead of 1 over cosine alpha, we call that the secant of the alpha. Right? That's the new definition. Essentially, you know what is the cosine, then you learn always the inverse of the cosine. It is called as the secant. What page number is that? 6. Is it clear? Everyone is good, doing good over there?
Yes.
Fantastic.
Yes.
Fantastic. And now, one more thing. We also talked about the sine of the alpha. This marker is also dying. I have to change this. Let me go to the black. We talked about the sine alpha. What is a sine alpha?
Y divided by R.
Fantastic. It's going to be y divided by the r. Then what happens if I come here and say, okay, it's going to be 1 over sine alpha. I flip it. It becomes then y. Becomes, I flip the right side. Then r goes to the top, y comes to the bottom. Then becomes r divided by y. Right? Then, there has been some mathematicians in the past, they came with this idea, because you are going to work a lot with the inverse of the sine function, which I mean that the 1 over the sine of an argument, then let's call that cosecant, which stands derived by the CSC alpha, which is 1 over sine of alpha. These are essentially the same ratios we have learned, but there is this tiny manipulation which changes the whole name of that ratio. Right? These are 2 things. Then whenever you see these kind of ratios, do not panic. These are essentially the sine and cosine, but they have been inversed. Everyone's doing fine?
Yes.
And now, we have only 5 minutes. Let's deal with this one to see if the secant of the x is an even or odd function. I'm going to do that for you. You please try this with the cosecant. Okay? In order to do that, you always know you have to inverse to transform the x to minus x. Then what is f of minus x? Equals to secant of minus x. But when I have the secant of the minus x, it's so ambiguous. I have no idea what is a secant. I come to write it based on the definition of the secant function, which I learned the secant is the inverse of the cosine, correct? Then essentially it's equals to the inverse of the cosine of minus x. I did nothing except I used the definition of the secant function, which is the inverse of the cosine function. And I know that what I have at the denominator of this function, which is 1 divided by the cosine of the minus x, is cosine of minus x. It becomes what? It's an even function that we learned. Huh? Which means that it becomes a cosine of the x itself. Which 1 over cosine of the x is what? Moving back to the same definition, is a secant of the x. Got a little messy, huh? I'm going to repeat that again. Guys, look at that. The f of x is secant of the x. I transform the x to the minus x. Then what do I have? I replace x to minus x wherever I see that. F of minus x becomes a secant of the minus x. I use a definition of the secant, which is 1 over cosine, and it becomes 1 over cosine of the minus x. 1 over cosine of minus x is 1 over cosine of it, because the cosine of minus x is cosine of the x. That's what you learned. That's what you essentially learned on the previous example, that the cosine of the x is equal to the cosine of the minus x, because cosine of the x is an even function. Then when we order the cosine of the x, I know that the 1 over cosine of the x, it's inverse of the cosine, which again is a secant of the x. You see the trick? We use the definition twice. Once here and once back. You transform it to this definition and transform it back. And I see that the f of minus x is a secant of the x. Then this function is even or odd?
Even.
That's an even function, because you see that f of minus x equals to the f of x. And that's the definition of an even function. Then so far, we saw that the cosine of the x and secant of the x, which they are related, they share the same characteristic. Because cosine is an even function, its inverse also, which is secant, is an even function. You got it, guys?
Yes.
Everyone is doing fine. Any questions?
No.
No.
How about Philip?
Philip is not here.
Philip is not. Oh, okay. Then if everyone is doing great, then I have to tell you guys something before we leave. I'm just going to give you thanks for enrolling into the science club. I'm going to give you 2 homework before the weekend. One of the homeworks is for the trigonometry. The other homework, I'm just going to introduce you to a topic which involves math. You do not have to do the math. You have to find out how math relates to that phenomenon. I'm going to give you an example how the brain works, and I give you the model for the math, and you have to write a page that how math describes the model of the brain. You do not have to do any math. And the purpose is that you get to know different fields for your future, that what you can do with the math. And you have the deadline for it until the next Sunday in 9 days, that you have to write your blog into the science club that you have already in there. And it comprises 10% of your final mark. Okay?
Okay.
I'm going to post it on the school website then, on the Schoology main page then. Then if you have no questions, I have to say have a nice day and see you all next weekend then. No, not next weekend, next Monday. Any questions?
No.
No? Then Rose and Gloria and Ferris, have a nice weekend. See you all next week on Monday then.
Bye.
Goodbye, everyone. Goodbye.
See you.
Bye-bye. See you later.